Welcome back. So I kind of sort of dread this section. Not that I think it's difficult to understand, but I know it's going to be something that is a fair amount of memorization. So let me explain. So far, all the ions we've been looking at are what we call monatomic. And the monatomic ions are ones that you have so that is one, atom that has gained or lost electrons. Now, when you go to I'll use ditto marks here, ions. Poly means many, so these are made from two or more atoms. And I kind of groan because there's not a really easy way to remember these ions and their names other than just sheer memorization. There's a couple of little tricks that I'll show you, but there's really no really good way that I know of. And if you know of a way, please show me, because I have never figured out how to do this other than through sheer memorization. And I would highly recommend you do this via flashcard. So I'm going to give you the name and the name, and I'm going to give you the formula. And I'd recommend that you kind of write one on one side and one on the other. And I'm going to try and keep it to the bare minimum. So there's tons of these polyatomic ions. There's like a dozen or so that I think are so common, I think you really need to know. And the book has another couple of dozen that I think are kind of obscure, to be honest. So I'm going to focus in on the ones that I think you really need to know. So you can waste your time. You can look and memorize the other ones if you want to. But I think if you keep your eye on the prize, these dozen or so are the most important ones. So let me go ahead and start a new slide and show you some. There is only one polyatomic ion with a positive charge that I want you to know the name and the formula of, and that is the ammonium ion, not to be confused with ammonia, although it is related through a proton. And the ammonium ion is the only positively charged ion that I think you should really know. And if we go down through the other ones, we have the OH minus ion, and we have the NO3 minus, and an NO2 minus, and we have an HCO3 minus, and golly gosh, we have a CN minus, and what else do we have? We have probably the hardest formula, C2H3O2 minus, and I think those are all the negative ones. So let's see, OH minus is the hydroxide ion. NO3 minus is nitrate. And closely related, NO2 minus is nitrite. Okay. You can look at the textbook for the spelling and formulas if you think my handwriting is sloppy. Yes, I did not win any handwriting awards. I'm sorry. The textbook has it nicely written out, or you can Google this stuff. HCO3 minus has a couple of names. The most common name for it is bicarbonate, although some people call it hydrogen carbonate. That's like the fancy, modern, standardized way to call it, which I think takes all the fun out of it. CN minus is cyanide. I always think it kind of sounds like it should be cyanide. The CN in cyanide just sounds right to me. And C2H3O2 minus, that's a mouthful, is acetate. Okay, and I think these are all the negative one ions you should know. So let me tell you just a couple of things about each one. So hydroxide is the ion in water that causes the pH to be above 7. It is also great at neutralizing acids. Nitrate is an ion that when it's combined with things, it tends to help them dissolve like crazy. Nitrite is an interesting ion that actually is capable of killing a spore called botulism. So in the old days, if you had uncured bacon, which tastes delicious, by the way, there's a good chance, right, it could contain this botulism spore, which is pretty darn deadly, actually. A lot of these spores are so poisonous, just a few of them will knock you off. So you add a little bit of nitrite to it, and if you add a little bit of nitrite, the spore can't survive, so it can't kill you. Interestingly enough, the meat changes color. It has that sort of pink color that, the meats like bacon and corned beef have these interesting colors. Unfortunately, it does have a slightly raised incidence of oral cancer, so you won't die of botulism, but if you eat these processed meats every day, well, you might have these large tumors growing out of your cheek, so maybe a double-edged sword, maybe. Best not to eat too much of it. Bicarbonate is an ion that is also basic, just like hydroxide. It can neutralize acids. Your body actually produces it, so when you eat food, your stomach contains hydrochloric acid to help the molecules unfold so they're more digestible. And all that acid, of course, you can't move on out through your body without neutralizing it. And so you secrete bicarbonate ion as it leaves the stomach. You secrete it in the intestinal tract to neutralize it. It's also part of the buffering system in your blood, which we'll talk about later. Cyanide is deadly poisonous. It will actually react with the oxygen-carrying compounds in your mitochondria and prevent electron transfer, which ultimately will kill you. And acetate is an extremely soluble molecule. I've certainly taken eye drops that have the steroid in an acetate form, and it's exceptionally soluble. Also, you can take cotton and you can modify it with a little bit of acetate, and you can make it maybe a little bit easier to breathe. It wrinkles a little bit less. So it's a pretty cool polyatomic ion. So those are the 1, 2, 3, 4, 5, 6 negatives and the 1 positive there. So we got a few more to look at. And okay, these are all the 2 negative ones. So we've got carbonate, CO3 2 minus, and we've got sulfate, and we've got sulfite. So let me go ahead and write those names. So this is carbonate, sulfate, and sulfite. Okay, the older spelling of the sulfur was PH, but actually the modern spelling is an F. So carbonate, sulfate, sulfite. And there's one more, and I think that's it. And I'll go ahead and write it on here. It is the 3 negative one, so PO4 3 minus, and it's phosphate. So how many did I say? There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so I lied. There's 11, unless I've forgotten one. Let me just double check my list. Nope, nothing else on the list. So those are the 11. So I lied. There aren't really 12. There's only 11 you have to learn. Now, a couple of little tricks here. So if you notice nitrate and nitrite, the only difference is that nitrate has 1 more oxygen and nitrite has 1 fewer. And if you look at sulfate and sulfite, you've got sulfate 4 and sulfite 3. So if you learn the normal one, okay, nitrate and sulfate, and you know the rule that you change the ending to ITE, you get 1 fewer oxygen, you automatically get these 2 for free. So it's not much of a rule, I guarantee you, I'm telling you, but it's an interesting rule nonetheless. All right, some sci-fi trivia here. So if you remember Star Wars Episode 5, The Empire Strikes Back, right at the very end, Han Solo, who's played by Harrison Ford, was frozen in this material. And I don't know if you've ever seen Star Wars Episode 5 or not, but it's absolutely awesome. And he was frozen in this material called carbonite. And as far as I know, carbonite does not exist in this universe. But if we know that carbonate is CO3 2 minus, you can guess what carbonite's formula would be. So remember when you got that ITE ending, you just subtracted an oxygen. So presumably Han Solo was frozen in no, he wasn't. He was frozen in CO2 2 minus. So we remove 1 oxygen from the normal form. So this is carbonate, and we get carbonite. So as far as I know, carbonite does not exist outside of the Star Wars George Lucas universe. But if it did, its formula would be CO2 2 minus. Cool, huh?